Okay, so let's have a look. A random sample of N, undergraduate university, if they were going to complete a second degree, 60% no, said no. So P is my population proportion, isn't it? So P hat, well, actually, the sample proportion is going to be P hat because that's the sample. We don't know how big the sample is yet. Write an expression for either margin of error at a 95% confidence interval. So the margin of error is that plus or minus 2 standard deviations. Specifically, though, it's 1.96 standard deviations. So 1.96 times P times 1 minus P on N, which gives me, just substitute your P and 1 minus P in there. 3/5 times 2/5 is 6 on 25 divided by N, 6 on 25N, yeah? All right, so what happens if the number of people in the sample were halved? What's the effect on E? So in other words, that N value from part B is now N on 2. So you can sort of see in here, instead of now being 25N, it's 25N on 2. So flip the 2. So we end up with 2 times 6 over 25N. Now, you could just write that as 12 over 25N, but then it's hard to be completely certain how that compares to the original. So what we want to do is try and get that 2 out the front as a common factor. And that way, I've got the 1.96 times 6 over 25N, which was the original error. And so you can see really clearly now that my error has just increased by a factor of root 2. All right, so tricky question, but just stay with the formula. Stay with the formula and put in the information that you've got. Okay, so question 2. A random sample of size N is drawn from a population, proportion of the population. We're interested in is equal to P. 2 standard deviations for P give a confidence interval of 0.7 to 0.8. Determine the values of P and N. Okay, so first things first. So my interval from 0.7 to 0.9, my confidence interval, so that means that my standard deviation, my mean value is in the middle of that. So 0.7 plus 0.9 gives me 0.8 if I divide it by 2. So 0.8 is in the middle. And if 0.8 is in the middle, it means my error is 0.1. Okay, so if I've got an error of 1/10, and that's equal to 2 standard deviations, so 2 times P times 1 minus P over N, the square root of that. So we sort of divide my 2 across to make it 1 on 20, square it. I end up with a 0.16 on N, manipulate the N across, multiply by 400, and we soon end up with N is equal to 64. So a 64.8 is my sample and my probability or proportion. All right. Similarly, student question 3, computer used to simulate a drawing a random sample from a large population. All right, so P hat represents a sample proportion, and in this sample proportion, P is equal to 1/5. I want to find the smallest integer value so that the sample size at the standard deviation of P hat is less than 1 on 100. So the rule for the standard deviation is the square root of P times 1 minus P over N. So I want that expression to be greater than 1 on 100. Okay. Actually, I want that the other way, don't I? Hang on, value the sample size. Anyway, my inequality sign is wrong there, boys, and I don't think I'm going to be able to rub it out. So let's just emphasize, I need 1 on 100 to be greater than all of that. So then if I square both sides, and then that'll give me 1 over 100 squared, which is 1 over 4 zeros. Yeah, and then I get 25N will equal 4 times 4 zeros, N is equal to 40,000 over 25. A little bit of long division, 25 into 40 goes once, with 15 left over, 25 into 150, 6 times, etc. And we'll end up with N is equal to 1600. So that's the point that we need. Part B, 23 students. We're actually in a class of 23 students. They all performed the experiment, and we found that one of the 23 does not contain the value of P. Okay, So the probability of drawing one of the sample spaces and not getting P is 1 in 23. So if we're going to take two of the confidence intervals we're going to draw, find the probability that one of them. Okay, so straight away, if we're taking 2 out of 23, sampling without replacement, so it's not going to be binomial. So we want one success, one failure, or one failure and one success. The probability of a success is 1 on 23, which makes then 22 out of 22. If I take it out in the first go, is the probability of the failure. And then if I get the failure first, it means there's 22 without it out of 23. And then once I draw one of them, I've got one out of 22 that I can get. Very quickly, we soon see that we end up with 1 on 23 plus 1 on 23, which is 2 on 23. All right, calculator, tech active. All right, so what have we got? Population where the probability of a success is 0.4, the random sample of 100 is taken, probability that the proportion of successes in a sample will be greater than 0.5. So we want the probability that P hat is greater than a half, which is same then as saying that the probability of X is greater than 50. So it's a binomial CDF, 100 trials, 0.4 success. I want from 51 to 100, which is 0.1672, 0.01672, sorry, which is 0.02, which is D. All right. Manager of hospital investor waiting for time to place in the clinic found to be the proportion of patients who wait more than 1 hour is 0.4. Random sample of N. The manager requires the width of a 99% confidence interval. Okay, so to be at the most 0.3. Okay, so this is a good one. So the width of the confidence interval. So if we just do a very small, so I want that width there, if that's the mean, I want this confidence interval to be only 0.3 wide, which means the error is in fact 0.15. Thought of train, idea through, all of a sudden M is equal to 0.15. What else do we know? I know that my P hat is equal to 0.4. So the other thing that's worth noting is we're obviously working at a 99% confidence interval, which is our 2.58. Now, if we work with 2.58 squared, I end up with 71.09. If I actually carry it out to a few more decimal places, I end up with 70.77. Now, depending upon how accurate you kept your 2.58, you're going to choose a different response. At 71.09, at 71.09, we would need to round to 72 because if it's 71.009, well, 71 would make you slightly above the 0.3, okay? So the correct response is 70.77, so that's the correct response. So you can see how the importance of making sure you carry enough decimal accuracy. All right, so just don't round values off. You can never be too accurate, okay? So correct answer there is 71, all right? Question 3, I must confess I've changed the question in your notes and I can't recall what it is, so one of them you might need to work out yourself. All right, what have we got? Question 4, random variable Z, standard normal. Probability Z is less than A is capital A. Probability that Z is greater than B is capital B. So you can see that in our little diagram. Let's get some appropriate colors back. So the probability that Z is less than A is in here. Probability that Z is greater than B is in here. So I want to find this conditional statement. The probability that Z is less than A and B given Z is less than B. Okay, so what's that equal to? So we can see the working out. The probability of Z between A and B and Z is less than B. Well, what interval satisfies both those conditions? It's that one. A less than Z less than B over the probability that Z is less than B. So you can see the color coding that we've got there actually. In between A and B, okay, so 1 is the whole probability, and we're going to subtract area A and subtract area B, and then the probability that Z is less than B in blue is 1 minus B, and we can just see straight away that that's option B. So we didn't have to manipulate anything too much there. What have we got? Similarly, group of 820 people were asked with their fixed 5-year term. 53% of the group favoured the idea. So P is equal to 0.53. The population is 820. An approximate 95% confidence interval. Okay, so my approximate 95% confidence interval, and in fact, without looking at all the other things, we can just sort of see straight away that 1.96 is my is my 95% confidence interval. So you suspect that the others aren't going to fit, and as actual fact, D is the one, isn't it? It's the standard deviation plus 1.96 times, and then minus 1.96 times. So D is clearly the correct response there. Finally, population tropical fish, 15% have a disease, random sample of 300. So I've got N equal to 300. The expected value of fish in my population to have the disease, I expect 45. Find the approximate probability of less than 20% of the fish in the sample have the disease. Okay, so what have we got? I know that my distribution, E of X, is 45, my standard deviation, the square root of N times P times 1 minus P, so that's my binomial distribution, is 6.8466. So if I have a 45, 6.8466 distribution, and I want there to be between negative infinity and, in reality, what's that, 20%, and 20% of 300 is 60, so we could just work that out. I end up with 0.99235. All right. Okay, so let's keep moving along. Fully Fit. Fully Fit is an international company that owns and operates many fitness centers and gyms, several countries, more than 100,000 members. Because they don't have them in the current climate. Someone completes S in less than 3 minutes, they are considered to be fit, set of exercise. Probability that any member of Fully Fit completes S in less than 3 minutes is 5/8. This independent of a random sample of 20. For the sample of 20, let X be the random variable represents the number of members. Okay, so since we have 20 trials, probability doesn't change. We're looking at binomial, aren't we? So it's a binomial distribution. Probability that X is greater than or equal to 10. Let's just fill in a heap of answers first, eh? Actually, we've got answers there on the left, haven't we? Is 0.9153 from my CAS printout. The conditional, X is greater than 15 given X is greater than 10. So it's got to be greater than 10 and greater than 15. So it's greater than 15 over greater than 10. If we put that into our CAS, I get 0.1953. All right, for samples of 20 members, P hat is the random variable of the distribution of sample proportions. Who complete less? Find the expected value and variance of P hat. So the expected value of P is just the expected value, which is 5/8. Now, remember the standard deviation is the square root of P times 1 minus P on N. So the variance is P times 1 minus P on N, which is 3/256. So with the square root of that's going to be my my standard deviation over there on your CAS dump. Find the probability that a sample proportion lies within 2 standard deviations to 5/8. Give your answer correct to 3 decimal places. So we've got P hat minus 2 times root sigma on N. Sorry, the square root of P minus P hat on N. So the standard deviation. And it's 5/8 plus 2 times the standard deviation. So that becomes 0.408 to 0.842. So looking at our 0.4 times 20 is about 8. So 9 on 20 is 0.45, 16 on 20 is 0.8. So they're the highest number of successes we can have to stay within that 0.4 to 0.842 interval. So that's the same as being between 9 and 16. And then if we look at our dump there, between 9 and 16, it's 0.939. All right. Find the probability that p hat is greater than 3/4 given p hat is greater than 5/8. So my conditional. So p hat is greater than 3/4 and greater than 5/8. Well, 6/4 is greater than, 6/8 is greater than 5/8. So that's the equivalent of probability of 3/4 over 5/8. So how many successes do I need to be greater than 3/4 or equal to is 15. 5/8 I need to be, well, 5/8 is actually probably 12.5 or something like that. So I need to be 13 or bigger. All right, so you need to make sure your number of successes satisfies the condition. So again, on my calculator, I end up with a 0.352. Paula is a member of Fully Fit Gym in San Francisco. She completes tests every month, is required but otherwise made regularly. So fitness levels varies over the months. Paula finds that if she's fit 1 month, the probability that she's fit the next month is 3/4. So fit to fit is 3/4. Not fit to not fit is a half. Okay, so I've just got a little sample tree diagram in there. So then you can see what the other two branches would be. Fit to not fit is 1/4, not fit to fit is a half also. So if Paula is not fit, so that's given. In pink there, that was the given condition. What is the probability that she is fit in exactly 2 of the next 3 months? So how can I achieve that? So there's the 3 different combinations that can lead me to be fit in exactly 2 of the next 3 months. So you've just got to be a little bit careful. The 1 represents my pink given. Okay, so let's have a look at the first one. If I go from not fit to fit, that's a half. From not fit to fit is a half, which is that blue line that I've just done. And then from fit, fit to fit is 3/4. And then I go from fit to not fit, which is 1/4. So they're the different pathways that I take to go from not fit at the very start into fit, fit, not fit. And then I just do the same thing for other paths to come up with the other scenarios. Don't forget, it is option 1 or option 2 or option 3. So we add each of those probabilities, all right, to end up with an 11 on 32. Continuing, Fully Fit surveyed all of its gyms throughout the world and found that the time taken by members to complete a different set of exercises is a continuous random variable, with the probability function defined as below. Find the expected value of W, correct to 4 decimal places. So don't forget the expected value is just W times G of W. So on your CAS, we're just going to define, So it's a bit harder to see that printout, so I'll make it a bit bigger. The integral between 1 and 3, there's my function for the first part of it, but with an extra x there because it's x times. And then I've got from 3 to 5, which is the limits of the second function, of x plus 29 on 128 times an extra x. Yeah, and if I add those two probabilities together, I get 3.0833. All right. 4 decimal places, 0833, yep. In a random sample of 200 fully fit members, how many members would you expect to take more than 4 minutes to complete? T, more than 4 minutes. So I want to go from 4 to 5, which means that's the second interval or the second part of the equation. Integrate that between 4 and 5, I get 0.2617. So that's the probability. If I have 200 people times by 200, I get 52 people. Right, from a random sample of 100 members, it was found that the sample proportion of people who spent more than 2 hours per week in the gym was 0.6. So my p hat is 0.6, my standard size is 100. Yeah, because it's a sample proportion. Remember we had 1,500 members or something like that. We've just surveyed 100 of them. Find an approximate 95% confidence interval for the population proportion corresponding to this sample proportion. Give values correct to 3 decimal places. So don't forget, my 95% confidence interval is 0.6 minus 1.96 times 0.6 by 0.4 over n, 0.6 plus 1.96 times 0.6 by 0.4, yeah? Or we come straight to our calculator and we can get our 0.504, 0.696 straight off the CAS. All right. What's next?